Hello, I'm audible. Hello. Please just confirm whether I'm audible or not. You can write in the chat box also if I am audible or not audible. Bala, am I audible, please? Or my screen is visible? If yes, we can start. We'll wait 2-3 minutes more. Maybe another student will join. Okay, good evening. Okay, fine. Okay, I'm audible and screen is visible. Both okay, that is fine. So let us wait 2-3 minutes. Maybe another participant will join, then I'll start. So today we are going to discuss assignment 5, that is week number 5. Okay, Deep is also joined already. Okay, that's fine. Okay, let us wait 2-3 minutes. Maybe participant will join, so we'll start within 5 minutes. Okay, so let us start. The first question is, what are the dimension of force? So here you need to tell just the dimension of force. Very easy question. So we have lot of questions. So let us begin with the very basic and the fundamental question. So what are the dimensions of force? So option here is M is correspond to your kg, or you can say the mass, and your L is correspond to the meter, or you can say the length, and T is corresponding to second or time. So now please you just try to write your answer in the chat box. This is very easy question, very fundamental question. Maybe you are studying these are things from your 11th. This is not a your okay. For question 1, you are telling option A is correct. M1 L1 T to the power minus 2. That is fine. Or Deep is also telling option A. That is very, very nice. So, okay. So how it is correct actually? Yes, option A is correct. How? Let me just explain for maybe for another students. For other students, I'll just explain very briefly. So in very short, force is equal to, you know already, the mass into acceleration, and acceleration is nothing but mass is your m and acceleration is velocity divided by time, right? Now you can write mass velocity is nothing but your distance per unit time, so t square. So now you can write very clearly here, m distance or length is l and t to the power minus 2. So like that you can write. So option A is correct. That is fine. Now we'll move on the next one. Next question is very, very important. Very easy question. I'll discuss here very fundamental things. So please just focus on the question number 2. The question number 2 is a 1 meter long model of ship is towed in a towing tank at a speed of 81 centimeter per second. To what speed of the ship of 64-meter long does this correspond? Option A 4.64 meter per second, option B 5.84 meter per second, option C 6.48 meter per second, option D 8.42 meter per second. So here you need to tell 1 meter you have the model something, let us assume 1 meter you have some model. Now you have model 64, that is 1 meter and 64 meter. This is your prototype, that is original thing. This is your model 1 meter, and this 1 meter for a study of something, 1 meter is towing of a tank which is the speed having the tank having the speed 81 centimeter per second. Now for 60-meter long, for 1 meter you need 81 centimeter per second. So for 64 meter how much you need? So this is the question actually. So now please just try to write your answer in the chat box. Very important question, very easy question also. If you have some idea, oh, for question number 2, Bala is telling C option 5.84. That is nice, very nice. Other student, please also try to write your answer. Okay. You are telling 6.84 means option C you are telling. Oh, option C. Okay, that's fine. Already here it's 6.84. That is fine. Okay. So other student, please also try to write your answer and try to calculate if you not know. Anyway, I'll explain very clearly here for whoever not know about it, the how to solve such type of questions, that is model prototype question. So I'll explain. No issue. But first you try to solve this question yourself, please. You will be feel very confident if you will solve yourself. Okay. I'll wait 1 minute more. If then after I'll explain. Here you need to understand one thing, whether you will apply your Reynolds number model or fraud number model, which one, whether fraud number or the Reynolds number. Okay, so let me just explain you. So here you have 1 meter your model ship, this is 1 meter, and this is your 64 meter ship. Now for this you have 81 centimeter per second speed tank. So what speed you need for this 64-meter long? So here you need to apply the fraud number similarities. But how you will apply fraud number similarity, how you will apply? So let me here explain you, or let me just explain you here. Here we have the space. So for the dynamic similarity we need to, and why we are applying here the fraud number similarity? Because in the surface flow, remember please, surface flow or gravity dominated flow, we need to apply your Froude number similarity. Remember please, always Froude number similarity means dynamic similarity. Froude number of your model is equal to Froude number of your prototype. How? So Froude number is what? Velocity divided by root Z and D. D is nothing but your area by top width. Velocity divided by G, area by top width. This is for your prototype and this is for your model. Right. Now, here you have model and prototype length and velocity. So you need everything in the length and the velocity form. So G will be cancelled out because for model and for prototype G will be the constant. Okay. And here you have, because you have the 2 dimension or 3 dimension, but here you have only the one length parameter. Remember please, 1 meter long and 64 meter long. So no, here actually the width of the ship is not discussed here, so we'll focus on only one length parameter, or we'll assume your horizontal length, that is the vertical, that is the your horizontal along, that is this length of the ship, and the width is both, that is the both are same here means the whatever you have, you are assuming the scale, that is horizontal scale and the vertical scale is similar. Here is the meaning. So horizontal scale or vertical scale is what I'll explain in the next question. That is very very important. So here area you can write, area by T you can write a single length parameter, because this is your meter square and this is your meter. So meter will be cancelled out. So single length parameter you can write here. So velocity divided by root L for meter, that is for your model, and velocity divided by root L. L here is not the length. This is a length parameter. We are discussing here is the dimensional analysis part. So we'll focus on that is your length parameter, not the length. So this is your prototype. Now you can write very easily your root, or let me just write here Vm divided by Lm Vp divided by Lp. So now you can write very clearly Lm root divided by Lp is equal to nothing but Vm by Vp. The ratio of these two you can write Vr is equal to root Lr. Now in the question Lm by Lp you have model length is 1 meter. So I'll go a little bit. Okay, model length you have 1 meter. Prototype means original 64 meter. Velocity for model 81 centimeter. So I'll put here the 0.81 meter per second for Vp. So after the calculation you will get, yes, so here you can see very clearly after the calculation you will get 6.84 meter per second. So this is the basic and fundamental procedure how we will solve such type of question, how we will formulate such type of question. This is very important for your understanding. So now we'll move on the next question. Remember please, such type of question is very important for your NPTEL final exam as well as your assignment as well as your any type of exam you will face in the your coming future. These type of question is very important. Even in the GATE exam also very important such type of question. So now we'll move on the next one. Question number 3. Very important. Now this question number 3 is linked with the previous one. So I have discussed about it also. Let us check whether you know or not. Which among the following is not a criteria to achieve similitude? Option A, symmetry similarity, kinematic similarity, dynamic similarity, conditional similarity. So here you need to just very clearly you just try to write your answer please in the chat box. You need to write the option in the chat box. Okay, Bala is telling for question number 3 is D option is correct. Conditional similarity. Okay, fine. So, okay, I'll wait 1 minute more. Maybe other student also tell. So, which of the following is not a criteria to achieve similitude? Geometric similarity, kinematic similarity, dynamic similarity, conditional similarity. Very important. Very important question. Okay, so here option 3 is for question number 3, option D is correct. Conditional similarity, no need for your the achieve the criteria of the similitude. Okay, so let me just read the detailed solution. The criteria required to achieve similitude are geometric similarity, kinematic similarity, and dynamic similarity. All these similarities play a major role in regard with the real-time applications. Similarity and similitude are interchangeable at times. Now I'll also read the detailed solution of question number 2. For SIP model, the resistance offered at a free surface is the significant force, and as such for dynamic similarity, the Froude number should be same for the model and prototype. So this is very important. Please remember all this. Now let us move on the next one. Question number 4, very important question. Okay, so the ratio of inertia force to viscous force is called? The ratio of inertia force to viscous force is called Reynolds number, Froude number, Mach number, Euler number. Just please try to explain here very easily. Not explain, just you try to write your answer here. This is just definition. Okay. Pala is telling option A is correct. That is fine. Other student, please also try to write your answer. Whatever you know, if you not know, you can just use the, I have already told you, you can use the Google also in the class, because here we are discussing. Okay, that's fine. Reynolds number. Yes, of course, this is a Reynolds number. Your Reynolds number is nothing but is inertia force, divided by your viscous force. What is inertia force physically? Inertia force is nothing but whatever you force by the your mass of the fluid, mass and the velocity, whatever you are facing the fluid, that is the force due to the mass and the velocity combinedly. That is the inertia force. And the viscous force is what? Due to the viscosity of your fluid. If your fluid have the more viscosity, you have more viscous. If your fluid have the less viscosity, then you will face the less viscous. Now let me just explain you very clearly. As you know, one thing, the viscosity is a fluid parameter. If you have the fluid from here to here and fluid is flowing everywhere in the pipe, let us assume the pipe section or open channel, whatever you can assume, this is the fluid property, viscosity. So everywhere the viscosity will be the constant. For here also, for even the boundary also, your viscosity will be the constant. Always remember, please. But why, as I have already I think in discuss in the boundary layer concept, near the bed, within the boundary layer, your viscosity force is dominated. Remember, please, viscosity force is dominated compared to your this the out of the boundary. Why? Because of here, because everywhere above the this boundary layer you have viscosity, and within the boundary layer also you have viscosity. But here one thing is plays very major role. One is your boundary effect, that is no slip condition. No slip condition play a major role here. So remember, please, that's why your fluid, if you will draw here the velocity diagram, your here is 0, then little bit increase, then after it constant. Always remember, please. So viscosity is a fluid property. It is everywhere is constant in the fluid, even at the boundary also. Okay, so let us move on the next one. Next question is very, very important. Okay, which of the following is dimension of kinematic viscosity? So here you need to tell the dimension of kinematic viscosity. For question number 5, dimension of kinematic viscosity. Very important. You can correlate with the dynamic viscosity, then you can compare your dynamic viscosity and the what is the definition of kinematic viscosity. Based on that you can calculate, if you not know. Anyway, I'll explain here how you will go step by step. If anyone not know the kinematic viscosity formula, even I'll here explain, or I'll tell you the one trick how you will remember the formula. for the kinematic viscosity. Sometimes student may get confused. This is the ratio, but which parameter in the numerator and which in the denominator. So that's little bit small trick I'll also tell here. So now please just okay, I'll give you 2-3 minutes. Within 2-3 minutes, please just try to okay. Deep is telling L2 T to the power minus 1. Means you're telling the option C. Okay. Nice. Bala is also telling C option. Okay. That's nice. So let me just explain you. Or for other student also, I'll explain. So option C is correct. But how? Okay. So you know already the kinematic viscosity is the ratio of your dynamic viscosity. What is the trick here? The kinematic viscosity, we are discussing about the viscosity. So viscosity term should be in the numerator. Remember please. If this is viscosity, then that will be the viscosity. Just for your remember, I am just telling some trick. So viscosity divided by rho, density. So this is the definition of your kinematic viscosity, or you can say this formula of the kinematic viscosity. Now, how you will calculate this the dimensions? So you know already the dynamic viscosity relation with your shear stress is nothing but Newton's law of viscosity. So tau is equal to del u by mu del u by del y. So from here, this is nothing but force divided by area. Mu u for the for your the dimension analysis, I'll write here uy. Now F is nothing but your already we have already discussed in the first question mlt minus 2. This is your L square mu, and for your viscosity or for your velocity is L by T. This is your L because meter per second, so that's why meter per second, and y is meter, so meter. So L will be cancel out here. 1 L will be cancel out. Now your dynamic viscosity dimension is m L minus 1 T minus 1. M, this L will be go in the numerator, so minus L1, and this will be go here, so T minus 2 and T to the power 1, so will remain T to the power minus 1. So this is your dynamic viscosity dimension. Now kinematic viscosity. So this is your for mu M L minus 1 T minus 1, and rho is nothing but kg per meter cube. Kg per meter cube means kg means mass, meter cube is your, this is m, remember please, this is m, not meter, and your meter cube is what? L cube. So this will be go again, will be cancel out, so you will remain with L square, L to the power 2 and 2 to the power minus 1. So hope other student will also understand. If you know, that's good. If you not know, please follow the procedure like that. Okay, very simple. So option C is correct here for question number 5. Now we'll move on the next one. Next one is very also important question. The quantity, okay, the quantity LR, this is LR divided by TR square is called ratio. What ratio? Whether it is already ratio is written, so no need to write here. So whether it is velocity ratio, acceleration ratio, length ratio, or the time ratio. For question number 6, LR is nothing but, remember please, your length of model divided by length of prototype, and TR is nothing but your time of model divided by time of prototype. So this is a LR and TR model ratio, you can say, or time ratio. Okay, so now please just try to write your answer. Okay, Bala is telling for question number 6 it is B, that is acceleration ratio. Deep is also telling B. Okay, this is acceleration. Okay, that's fine. Maybe. Let me just check. Yes. Why? Because you know already length parameter and the time parameter. Length parameter and the time parameter. We are discussing about here the your and how it is here you can see very clearly. Your acceleration is nothing but AR is nothing but your model acceleration and prototype acceleration. This is very simple. Now acceleration is what? Now you can write this acceleration in terms of velocity. How we will write? Let me just explain a little bit more for other students. Your acceleration is model velocity divided by time of the model. Prototype, prototype velocity divided by time of the prototype. So you can write like that. Let me just explain here. So VP is your VR. Okay. For acceleration, we are writing here. Okay. Why it is written in terms of your V square at the place of, okay, is it any mistake here? This is your V acceleration is nothing but here it will be the time, means here you can write the square, no issue. Not time, because in the terms of you are writing in the V, so no need to write the square here. Is there any mistake? Okay, let me just go through. So VR, and for TM divided by TP, you can write very clearly here the TR for your acceleration ratio. Okay, I don't know where I'm doing the mistake. Okay, actually this is correct. Okay, in terms of V, uh, we are correct here. But here it means the VR square means that is actually not able to get. Okay. I think let me just go through the Froude number similarity. I think it is related from here. VM. divided by your, that is Vm divided by root Z, or let us write here the one length parameter Lm, and this is for prototype. So Vp divided by Lp. So Vr is equal to Lr. So from here we can write very clearly root Lr. This is we can write here. So for root Lr we can write root Lr, and how we will calculate for the time. So for the time also we can calculate like that. So this is another way. For the time how we will write, let me just see, because here it is very directly it is written, so that is very difficult to understand. So let me just go through one by one. Vm divided by your Lr, Lm, Vp divided by Lp. So if we write in terms of your time, if you want to find out, so we can write very clearly here. Velocity is nothing but meter per second. So L by T we can write here. So at this place we'll write here, at the place of V, Lm by Tm or root Lm is equal to Lp by Tp root Lp. So here we can write root. Now we'll move a little bit lower. So Lm is nothing but your, so Lm will cancel out, the here only root Lm divided by Tm is equal to root Lp divided by Tp. Okay, so here root Lm divided by Lp is equal to Tm by Tp. So from here we can write Lr is equal to, or root Lr is equal to Tr, or one thing we can write Lr is equal to Tr square. So this we can write very clearly. So this is linked with here. So one thing you can see very clearly here, your Lr is nothing but, that is the Tr square. One thing we are understanding very clearly, and Vr is nothing but, here we have already seen the Vr is equal to the root Lr. So Vr square is equal to your Lr. We can write very clearly because Vr is nothing but your root Lr. So this step is very clear now. After the explanation, now it is very clear. But how from acceleration to Vr square and the Lr? This is okay. How this explanation I'll explain you. I'm very, one thing I can guess from here also. The your Vm divided by your G, this is the acceleration unit, or Lm. So if we'll write is equal to, let me go little bit above here. So Vm divided by root ZLm is equal to Vp divided by root ZLp let us take the square both side. So after squaring, so we will get Lm square divided by ZLm is equal to VR Vp square divided by GLP. So if we take this unit, this also M and this also P, so from here we can write this your acceleration unit. This is also your acceleration unit, meter per second square. So maybe here from this, if we'll write gm by gp, zm by gp, so we can write here your vm square divided by vp square divided by, okay, lp by lm into lp by lm, means here you can write vr square divided by lp by lm is nothing but 1 by lr, 1 by lr. So by unit wise you can write very clearly these things. Whatever here it is written, very straightforward. Here it is written this thing, vr square by lr. This is the way for writing. If you are going with this, and now I have already explained you how VR is equal to LR and LR is TR square. So like that you can explain very clearly. Okay. So here option B is correct. This is your acceleration ratio. So hope you will understand how we will play with this, the unit things in the dimensional analysis. This is very important. Remember please. Okay. So now let us move with the next one. The question number 7. When there is a dominant action of gravity, the number similarity used, whether Reynolds number, Freud, Mach or Euler, the domination of the gravity, already I have explained you in the question number first also. Okay, Bala is telling the acceleration is u into du by dx. Okay, I'll see. Okay, I'm thinking of first for question number 7 you are telling option B is correct. Okay, that's fine. Okay, yes, this is the also you are telling right, u and du by dx is the acceleration. Actually we are writing in the, okay, let me just finish for question number 7, then I'll come on that. Okay, okay, Deep is also telling B option, that is fraud number. Okay, already I have explained you also how this, when you will the flow is dominated by the gravity, will go with the float number similarities. Okay, so now the this Bala is telling this acceleration is also we can write u du by dx. Yes, we can write. You know already the acceleration in the x direction is what in the fluid mechanics, u du by del u by del x, v the convective acceleration del u by del x del y plus w del u by del z plus your del u by del t. We write actually this is your convective acceleration, this is your this is your local acceleration. So now here also for the acceleration, actually you see here the unit u del u by del x. So you can write very clearly when you are going for the dimensional analysis in the fluid mechanics, you can write very clearly here u into u by x means v square divided by lr divided by l means your velocity and L, and you know already you using the fluid number similarity, your if you are writing here the Vm, that is AR, so very easily you can write these things VR LR. If here is square and VR is, that is VR square is nothing but your LR, and LR is nothing but TR square. Okay, so this is a very simple explanation. So this is actually go with this actually. Whatever I have explained earlier, this was very long procedure, but as you have seen, this is very as Bala has told. So we can go with this also. Yes, we can go with this also. So this is very long procedure what I have discussed earlier. Okay, that is very nice. We have discussed the two way here. How we'll go with this the similitude. As you can see here, as I was comparing this the fruit number similarity, you already see we come on this only. The similar thing. As we will go with this definition, we will come up with this. So actually, this procedure is you follow please for the acceleration similitude. Now we'll move on the next one. Question number 8. The question number 8. Similarity of motion between model and prototype is called geometric similarity, kinematic similarity, dynamic similarity, all of these. The similarity of motion. Very important. So we are discussing about here the similarity of motion between model and prototype is called. Okay, Bala is telling option B for question 8. That is kinematic, that is fine. Other student, please also try to write your answer in the chat box. For similarity of motion between model and prototype is called what? Very simple question, please. Other student, please try to write your answer. Kinematic similarity, that's fine, very nice. Yes, because here we are, the question is asking about the motion. Remember, please, one term is very important here, motion. Similarity of motion between model and prototype. Not overall, we are here talking the similarity. So for motion, we'll go with the kinematic. Remember, please. Yes, you both are correct here. So option B is correct for the question number 8. Now we'll go on the next one. Question number 9. The square root of the ratio of inertia force to compressibility force is called Reynolds number, Froude number, Mach number, Euler number. The square root of ratio of inertial force to compressibility, the force is called what? For question number 9. Very important question. Okay, for 9 you are telling C, that is Mach number, Bala is telling. Other student, please also try to write your answer. Very easy question, not very. But remember, please, these are the question is very, very important. The ratio of your this non-dimensional parameter, non-dimensional parameter definition is very, very important, as well as the dimensional analysis, how I will tackle the question, how I will solve the question. So these are also very, very important. Very fundamental thing, if you will remember the some fundamental procedure how to solve, that is the unit conversion and the unit ratio maintains, how you will maintain the ratio of the unit, means you cannot add the meter with the time unit, you add only the meter unit and the meter unit, you can multiply only the meter and meter, then will you get the meter square, not meter and t. So like that, if you will know some fundamental, then very easily you will get such type of that is the dimensional analysis type of question you can solve very easily. Whatever you have learned in your 11th class, the similar, this is the advanced version of your that is in engineering you are seeing in this chapter. Okay, so see, that is Mach number. Okay, let me just check. For that is the square root of the ratio of inertial force divided by compressibility. Yes, this is the Mach number. Always remember, please. Mach number is nothing but ratio of inertia force divided by your compressibility force. This is your Mach number. This is actually used in the aerodynamic. Remember, please. Always remember. Now we'll move on the next one. Okay, this is the last question for this first, that is your assignment 2025. Then we'll solve the assignment 2024 also, no issue. So question number 10. Laboratory model of a river is built to a geometric scale of 1 is to 100. The fluid used in the model is oil of the density 900 kg per meter cube, and the highest flood in the river is 10,000 meter cube per second. Highest flood in the river is 10,000 meter per second. Find the corresponding discharge in the model. So you have river and you need to find out the discharge in your model if your geometric scale is 1 is to 100. 1 is to 100, remember please, if 100 meter in the river, you are assuming 1 meter in your flume or laboratory. For question number 10, please solve this question very precisely. This is very, very easy question. You have 2-3 minutes, or you can take the 4-5 minute also, no issue. O- Okay, Bala is telling for question number 10, A option. Okay, fine. Other student, please also try to solve this question. Very easy question. Here you need to maintain the discharge. Remember, please, the ratio of discharge you need to how we will find out, because we are discussing here the river. As you know, the river is the gravity force dominated flow. So here you need to apply the float number similarity. Now you know already in the float number similarity the velocity is there and the length parameter is there, but you need to convert this length velocity parameter in terms of your discharge, then from the discharge parameter, or you can solve very easily in another way also. You know already the discharge is nothing but, okay, why is density is given here? Yes, you know already there is if we are discussing about here the fruit number similarity, there is no relation of the density here. So density is given here for the confusing, please, in this question, for the confusion, for the creation of confusion. So there is no meaning of the density here, because density is maybe, as you have seen in this question, the density is given, maybe your mind will go on the whether we'll use the Froude number similarity or the Reynolds number, because in the Reynolds number we consider the density. So for the creation of the confusion, the question is given the density. Okay, so now I'll just solve this question very easily. So you know already, as I have discussed in the earlier also, the discharge is nothing but area into velocity. So Qm and Qr is your A, Qp actually, not R. So here you can write Qr is equal to AR means LR square. AR means meter square. So for meter square you can write the length parameter square, and the for velocity VR square. VR, for velocity you write, as I have already explained, the VR is nothing but from your Froude number similarity. Let me just explain again, very important. For Froude number you know already, V by root G, and here is the length parameter. Length parameter is what? The D, area by top width. So here this is meter square, this is meter, so we'll get with the length parameter. So now Vm you can write for the, when you will dynamic similarity maintain. So Frm divided by Frm is equal to Fr prototype. So that's why I'm writing here F velocity m divided by GLm is equal to Vm Vp divided by GLP, the prototype. From here this is, so GG will be cancelled out. So Vm by Vp is your VR, Vm by Vp is VR, and Lm by Lp is root LR. So your VR is equal to LR. So from here, from your fluid, that is Froude number similarity, we can write LR square into LR, root LR, or you can write LR half. So when you will this right, LR is equal to 2 plus 1 by 2 means 5 by 2, means your discharge QR is equal to nothing but LR 5 by 2. Very important. Now the question is, Qm divided by Qp is equal to, LR is given in the question, 1 by 100 to the power 5 by 2. Now you need to calculate here the Qm. Qm is equal to Qp, that is 10,000, here it is given 100 power 5 by 2 means 100, that is 10,000 into 1 by 100 power 5 by 2. So after calculation you will get, let me just check, 0.1 meter cube per second. So this is the calculation, please. Finally, let me just check the calculation also. Yes, that is 10,000 into 5 by 2 means 2.5. So finally we will get 0.1 meter cube per second. So very important. So here what is explaining, let me just explain this also. This is also very important. So LR is nothing but, AR is nothing but LR square into VR is nothing but meter per second. V what? Meter per second means LR square LR divided by TR. Is it right? So this will LR is cube divided by TR. So this is coming, and TR is from your fruits law is TR is nothing but root LR. So when you will write here the root LR, LR cube divided by root LR. So means 3 minus 1 by 2. So again you will get 5 by 2. So finally you will get LR to the power 5 by 2. So from here also you can get. But you need to use. I have used the your float number for your velocity ratio. For this also you need to use the float number for your TR ratio. So you need to use the this for any if you will go with this calculation, this actually idea, this concept, you need to use the float number law, float law, and for whatever I have explained also you need to go. So let me just explain you how this TR is equal to root LR. Let me just try. So Vm divided by root G will be cancelled out, so that's why I'm writing directly, and Vp divided by root Lp, and V is nothing but meter per second means Lm divided by Tm root Lp. Vp is Lp divided by Tp root Lp. So Lp will be, so here you will get root Lm divided by Tm is equal to root Lp divided by Tp. So your Tm by Tp is nothing but Lp by, sorry, Tm by Tp is equal to root Lm by Lp. So you can write this Lr, or this is Tr. Tr is equal to Lr, root Lr. So that's why here it is written. So hope you understand the first 2025 assignment. Now we'll move on the next assignment 2024. So this is also very important. So here you just please read the first question, very important. Now I'll take here 5-minute break, please. If you want to also take the 5-minute break, you can take for your water and all. Okay. So if you not want to take the break, you just read the question and just try to solve the first question. Okay, so now we'll start the next assignment number 20. That is same week 5 assignment, but 2024, not 2025. So the question one is, let me just go on the PDF. Okay. In the model test of spillway, the discharge and velocity of flow over a model were 2.5 meter cube per second and the velocity was 1.5 meter per second respectively. Calculate the velocity over prototype, which is 36 times the model size. Option A 3 meter per second, B 6 meter per second, C 9 meter per second, and D 12 meter per second. So please just try to calculate. The first question is very very important. Okay, so Bala is telling for question number 1 is C, that is 9, and Deep is telling 9. Okay, you both are telling the 9. Let me just check and we'll move again. We'll move further on the next question. Let me first check. Yes, 9 is correct here. So here you need to calculate the velocity over the prototype and the model velocity is given, and which is 36 time of the model, means LR is here, it is given is, that is Lm by Lp. If your Lm is given 1, so Lp is given 36. This is your Lp is your 36 times of Lm. Now this is correct definition, which is 36 times of the model size. If model size 1, you LP you will get 36. That is the okay. Calculate the velocity over prototype. So we are discussing here the spillway. So again we'll use here the Froude number similarity. Remember please. So now you know already the velocity. Vm is 1.5. You need to calculate the VR or V prototype. Now formula for VR is equal to root LR. So Vm in the question is given. Vm is 1.5. Vp you need to calculate, and here is root 1 by 36. So Vp is 6 into 1.5. So we will get here. Hello, anyone want to say something? Okay. So now here you will get 9. So here in the solution one thing is mistake here. So here you have 1 by 36 LR. Okay, here the okay, as we are discussing from the previous, so your VR is nothing but Vm by Vp and LR is nothing but, so please follow this one, Lm by Lp. Always remember please. So here LR is 1 by 36 as you know already. LR is Lm by Lp. So here from Lm by Lp you will get Lm by Lp 1 by 36. So now you will use this. Now you can solve like this. Okay, so we'll move on the next one. Next question is dimensional analysis is used. Question number two. Dimensional analysis is used to test the dimensional homogeneity of any equation of the fluid motion, derive rational formula for a flow phenomena, derive equation expressed in terms of non-dimensional parameters. Option D, all of the above. For question number two, you need to write your answer in the chat box. Very important. For question number two. Okay. Indrajit is telling D option. Bala is also telling D option. All. Fine. Other student, please also just try to write your answer. Okay, so yes, here all option is correct. We use dimensional analysis for all of these, whatever is explained in option A, B, C, D. We'll use means we use for the dimension to test the dimensional homogeneity for any equation. We use for derive the rational formulas for a flow phenomena. We derive the equation expressed in terms of non-dimensional parameter also. So remember please, very important. So the both statements are correct. So detailed solution here it is written. The dimensional analysis is used to test dimensional homogeneity of any. Okay, similar thing is written. No issue. Will not read. Next question. For question number three, in which of the following method of dimensional analysis a functional relationship of some variables is expressed in the form of exponential equation, which must be dimensionally homogeneous? Remember please here, in the form of exponential equation means something a to the power b or x to the power a, like that, the exponential form e to the power x, like that. So now just think on that, which option is or which method is used exponential equation and which must be dimensional homogeneous. This condition also should be followed. So Buckingham pi method, Rayleigh's method, Brisbane method, and the matrix tensor method. Option D. Which option is correct here, please? Okay. Bala is telling the Brisbane method. Okay. Bala is telling the Brigman method. Okay. Other student, please. Whether it is Brigman, Relays, Buckingham, and Matrix. Okay, Indrajit is telling option B, relays method. Okay. Okay, Bala was telling for question number three, it is B option, relays. Okay. I was thinking you are telling the C option, that's why. Okay, okay. That is question number three, option B. I was thinking the option three you are telling. Okay, no issue. So you are also telling the relays. That is fine. Okay, in this is that's fine. I understand you are telling the question for question number three, B option. That is okay. Yes, relays method. So you both are correct. The in the exponential form we write actually in terms of the exponential equation and dimensional homogeneous. We'll follow these things also in the relays method. Remember please, relays method is very important. But sometimes relays method have some limitation. That's why we go for the Buckingham Pi theorem. So also remember please, I'll suggest you please see the limitations of the relays method. Then you will understand why we need the Buckingham Pi theorem. So this is also important. Relays method shows a functional relationship of some variable is expressed in the form of an exponential equation which must be dimensionally homogeneous. Okay, so now we'll move on the next one. The next question is about the Buckingham Pi theorem. In dimensional analysis of Buckingham's pi theorem is widely used and express the resulting equation in terms of the repeating variables, option B, geometric, kinematic and the dynamic variables, option C, n minus m dimensional less parameter, option D, n dimension less parameter. So just think on that. The widely used and express the resulting equation in terms of n dimensionless parameter, n minus 1 dimensionless parameter, the repeating variables, and the geometric, kinematic, and the dynamic variables. Very important question. Okay, for question number 4, Bala and Indrajit both are telling the option C, n minus m dimensionless parameter. So what is n and what is m, please you can explain. Deep is also telling option C, that is fine. But if you know what is m and n, so that will be also very easy for me actually. What is n and what is m? This is very fundamental. So you need to know whether it is n and m is the same thing and what are these. You can write in the chat box. I'm waiting please. So what is m and n? If you not know, please you can search. Okay. Okay, n is the variable and n is the dimension. Okay, is it like that? N is the number of parameter, m is the repeating parameters. Okay, means if you have n, you are telling the n is a number of parameter. Let us assume you have the 10 parameters and the repeating parameter is 3. So you will get the dimensionless parameter is 7, right? Okay, and Indrajit is telling the n variable and the m dimension. Okay, if you not know, please you can just Google and just try to get the exact answer. No issue. Anyway, this is a discussion class, so you can use, no issue here. if you not know, if you know, just try with your mind and yourself, then here you can write also, no issue. Actually, in the Buckingham pi theorem, we need to write the pi terms. Okay, so yes, so here your n is a total number of parameter and m is your repeating parameter. Remember, please. So Bala is correct here. So detailed solution is in dimensional analysis. The Buckingham's pi theorem is widely used and express the resulting equation in terms of n minus m dimensionless parameter, and we select this m1, that is repeating parameter, based on the it should be one from geometric, kinematic and the dynamic variables. So this is also, remember how we will select this m. So now we'll move on the next one. Next is also very important. Distorted models are required to prepare for which of the following? Distorted models required to be prepared for which of the following? Rivers, dam across very wide rivers, harbors, all of the above. Distorted model. Distorted model means here, just for, actually for distorted model is nothing but just simply I'll tell you, you have some horizontal scale and you need some vertical scale for modeling. You need dynamic similarity, you need kinematic similarity, all of things you need. Let us assume you are using the horizontal scale is 1 is to 100 and vertical scale you are using 1 is to 10. So this is a distortion, because when you will use the both are the same, horizontal and the vertical, then that will be fine. But you are using the here the different. If your model and or prototype float number is similar and you have used these things, that is horizontal scale 1 is to 100 and the vertical scale is 1 is to 10, your model is distorted model. Not completely your model is the uh, similar model or the dynamics, that is the similarity, that is not follow the all similarities. So one thing you also know, please, the ratio distortion ratio is how much? Horizontal by vertical, so 100 by 10 means distortion ratio here is 10. So okay, let us, I'll come later again once I want to know answer from your side for this question. So all harbor, you are telling, Indrajit is telling harbor, that is C option, and Bala is telling option D, all of the above. Okay, fine. Other please. Okay. Okay, so let me just explain you. So here, for modeling of rivers, dam and harbor, you need to the distorted model for all. You cannot go with the exact model without any distortion. Why? Because in the modeling you need to flow the water depth. You need to maintain also the water depth, please remember. So for maintaining the water depth, for also you have some features in the river system, sand depositions, what should be the sand deposition height in the river and what should be kept in the laboratory. So that are things we need to take care about in the laboratory. So we have to go with the distortion model. There is no way. When we will assume the exact modeling, that is the exact your this when we will go with the exact the same scale, horizontal and the vertical, you cannot actually, let us assume, let me just explain you. You are modeling the horizontal length of the river is 1 kilometer, or let us assume the 2 kilometer, 2 kilometer, and some the sandbar deposition here, let us assume this is your 1 meter or 2 meter, let us assume. So if you are using 1 is to 100, so how much you need to in the laboratory for the length and the width, let us assume width is here 1 kilometer, or 1 kilometer width is 1 kilometer. So for width in the laboratory you need to 1000, that is 1000 meter divided by 100, so 10 meter width you need, 10 meter, 10 meter width, or the length you need 100,000, or this is your 2000 divided by 100, so length you need 20 meter. But what about the height of this, that is sand deposition? If you are assuming 200 2 meter divide by 100, so it is 0.02 meter, means 0.02 meter means what? 2 centimeter. So as you can see here, the 2 centimeter means in comparison to your 20 meter length and width of the 10 meter, and if you are putting the 2 centimeter the things of the deposition, so whatever you want to capture the effect of this deposition in your, that is the river, so you cannot capture, because 2 centimeter is very very thin, very very low height. So that's why we did the distortion. Let us see. If you are assuming the vertical scale 10, so here you will get, this is 2 meters, so 0.2 means 20 centimeter. So 20 centimeter height will be this much. So that will show the effect of this deposition on the, when we will measure the data, that will show. 2 centimeter will not show the effect. So that's why we need the distortion. Always remember, please. Here very clearly explained. Let me just read. Hydraulic modeling of river, harbor, estuaries, etc., which have the longitudinal slope and large aerial spread, pose many particular problem in strict similitude is attempted. To overcome most of these problems, they are usually modeled by using distorted scales. Distorted models are those which are not perfectly geometrically, remember please, distorted models are those which are not perfectly geometrically similar to the prototype. Means perfectly geometrically similar means you are assuming as per the your scaling you are getting 2 centimeter, but 2 centimeter will not show the effect, so you are assuming the distortion model 1 is to 10 for the verticals, we are getting 20 centimeter. This is the things we are we are not using the same scale, so that is the same, that is the things. So different scale ratio is used in different direction, so this is the meaning. Different scale ratios is used in the different direction, particularly in case of shallow rivers where depth is small compared to the width. Without distortion, the depth of the flow in the model will be so small that measurement may not be accurate, and the surface tension effect, remember please, and the surface tension effect will be prominent, which will not present in the prototype. So this is the effect, surface tension effect you will face, which is not in the prototype. Hence, it is necessary to distort the model in the vertical direction. In the design of the model, hydraulic similitude is of the prime importance. Remember please, in the design of model, hydraulic similitude is of the prime importance and not the geometric similitude. Therefore, by distortion of the model scale, even though the model is not low like a prototype, but it gives the satisfactory result. Not exact, but satisfactory result you can use. So remember please, this is very conceptual. This was a very conceptual question, and also the explanation is very, very good here. Now we'll move on the next one. Now the same here. We have used the question. Let me just read the question, then I'll explain you. Question number 6. In a tidal model, the horizontal scale ratio is 1 is to 500. The vertical scale is 1 is to 50. Here you can see, please. The vertical scale and the horizontal scale is different. In the previous question, whatever we have solved already, there was only single scale ratio. That is 1 is to 100 and whatever. But here is the vertical scale is different, horizontal scale is different. So now you can understand the effect of what is the distortion model and what is the distortion. Here you can see in this question. What model period would correspond to the prototype period of 12 hours? So whether it is 610 seconds, 620 seconds, 630 seconds, 640 seconds. So you have the four options here, please. Just try to calculate. Try to calculate and write your answer in the chat box. You are asking about Indrajit asking the previous year question. So previous year question, actually I am already uploading the previous year question, no issue. I am already uploading in the Google Drive, so you can access. You can access very easily, no issue. All questions already I have uploaded for week 1, week 2, week 3, week 4. Now today we are discussing week 5, so also I'll upload after this class. I'll upload the week 5 previous year question, so you can directly download, no issue. Even I am recording this video, I'll upload this video in YouTube and link will provided from the NPTEL side. You will get for exam. You are asking about the final exam? No, no, no. Final exam answer you will not get. No, no, no. For final exam you will not get. For the final exam questions you will not get, please. The NPTEL not provide you the final year questions. Maybe you can ask to the this NPTEL whatever you are NPTEL. I think you can write the mail to, I think NPTEL is handling the IT Madras, so maybe you will get one mail ID. When you will when you will register this course, you will get something like that. The contact address you will contact, mail ID or phone, whatever you will get. You just ask to whether it is able to get the final NPTEL exam, final NPTEL exam your question or not. So maybe that person will guide you very clearly. As of now, I know the final exam NPTEL this question you will not get, because I am teaching, I have previously, actually I am teaching continuously from the last 6 semesters. In the coming semester, I'll just discuss the fluid mechanics. In this semester, I am discussing this hydraulic. So like that, alternately. But I didn't get also the your final year exam questions. So you can ask the NPTEL, the authorities. Hope they will tell you. Okay, for question number 6, you are telling option A, 610 second. That is fine. Other student, please. For question number 6. Okay, Bala is also telling option A. So already we have seen the time relation with your ratio, that is this scale ratio. Here we'll also use the fraud number similarity. So FR for model is equal to FR for prototype. So here VM divided by root G. Now I'll write here the area by T. This is M, this is M. VP divided by G AM AP divided by TP. So here you have the prototype, time is 12 hours. You need to calculate TM. If you have the horizontal scale, that is horizontal scale ratio 1 is to 500, and the vertical scale is this. Okay. So here this VM by VP, the AP by TP is what? This will give you the vertical one. Remember please, area by top width we are discussing here. So this will give you the vertical. Let me just write again here, VM by L M. This is for the vertical, because area you know already, area by top width give you the whatever, you will get the length parameter in the vertical direction, remember please. And LM by VP by LPV vertical. Now your velocity is what? Meter per second. This is your length, that is the along the horizontal scale. Velocity is associated with the horizontal scale. So LM horizontal and TP TM. So here you can write LM horizontal divided by TM root LMV vertical. This is your H. LPH divided by TP root LPV. Now LM by LMH by LPH into LPV LMV root is equal to Tm by Tp. This is LP by LM. When we will write LM by LP, this will go. Now LM by LP is nothing but the horizontal scale we are discussing here. So LR horizontal divided by LP by LM. This is 1 by LR. If this is vertical, so 1 by here is 1 by LR vertical is equal to TR or Tm by Tp. So now you can write very clearly here. This is root also. So 1 is to 500 divided by root under 1 is to 50 is equal to Tm you need to calculate and Tp is given 12 hours. So you need to calculate in the second. So you need to convert this R in the second. So 12 into, let me just go a little bit below. So 12 into, so Tm is equal to 12 R into second, you will multiply with 60, it is in minute, then second into 1 by 500 divided by root under 1 by 50. So finally you will get 0. Not finally you will get, let me just go 610 second. So this will be your final answer. Remember please always. So how we will go with this, the very fundamental thing. So just here the dimension, if you know the dimension, you can play with the dimensions, no issue. Such type of question is very easy. The thing is you need to play with the dimensions. You need to know. Okay. So for question number 7, the dimensional formula for relative density is dimensional formula for relative density. Okay. For question number 7, please just try to write your answer. Dimensional formula for relative density is, okay, you are telling the D option. Okay, that's fine. Because the relative density is nothing but ratio of density by density. So option D is correct. Yes, fine. Here explanation is also given. The relative density is the ratio of density, mass of the unit volume, mass of a unit volume, that is density is, definition it is given. So the relative density is the ratio of density of a substance to the density of given reference material. So specific gravity usually means relative density with respect to the water. So it is dimensionless quantity and has no unit. Means the density of any material divided by density of water. This is your specific gravity. And when we talk about the relative density, then your material and divide by standard fluid. Whether you want to see this density of this material with respect to oil, with respect to your mercury, with respect to honey. If you are looking this material density with respect to water, so you can say the specific gravity. If you are looking with some another reference point, if you are taking, then you can write the relative density. So this is the brief. Otherwise, when you are using the specific gravity or relative density, if you are using the water, you can say this is the specific gravity, no issue. Okay, so now we'll move on the next question. A symmetrically similar spillway model is constructed to a scale of 1 is to 12, corresponding to a discharge of 998 cubic in the prototype. The discharge in the model in cubic will be 1, 2, 16, and 64. Very easy question, please. We have already discussed the discharge relation with the LR. So if you know very clearly, you can write just one step calculation. Okay, you are telling the B option, that is 2. Okay, nice. Okay, you know already the discharge is nothing but area into velocity. Okay, area into velocity. So here you can write LR. If you are discussing with QR is equal to LR square, and the velocity you know already root LR. I have already discussed lot. So LR to the power 5 by 2, or you can say 2.5. So here prototype you know in the 9998. So QM is equal to Q prototype. LR is given 1 by 12 to the power 2.5. So QM is equal to nothing but 998 into 1 by 12 to the power 2.5. So finally you will get, let me just check, 2. So this will be the correct 2 Qmax. So option B is correct here. Remember please for question number 8. Now the next question. A river model made of a length ratio is 1 is to 50. Depth scale ratio is 1 is to 16. Means same thing whatever we have discussed earlier. A peak discharge of 25600 meter cube per second in the river will be simulated in a model with a discharge of, very important please, the length scale ratio here you are using 1 by 50, and the depth scale ratio you are using 1 by 16. So what you will use the discharge here in the your model in the laboratory. So as you know already, let me just no answer from your side, then I'll discuss. Actually we have already discussed in the first question I think. So I'll show you the first question, then I'll directly write here the formula. Okay, so let me just go. So here you have the, let me just show that first where we have discussed here in the question number 6 we have discussed the your will use in the numerator, that is the for velocity, we need to use the horizontal, and for the denominator of the float number, we need to use vertical one. So similarly here you can write very easily. For question number 9. Okay. So similarly you can write here. Discharge is area into velocity. So area is what? Area is the cross-sectional area, remember please. So here you have the depth and width. So length, for the length you are using the horizontal. So if you are writing for the first area is L into B, length into width. So what you will write here? Not length, this is depth. So for depth, so LR for vertical and LR for horizontal. And for the your velocity, you know velocity is root L, but it root LR. But this LR is for your vertical or for your horizontal. This is very important. This VR, LR you know already. So how? Let me just explain you here one thing very important. FR is equal to your V divided by G into here the vertical things. And V is nothing but V is a, when you will write V you will get root L vertical. So that's why here is the vertical, LR vertical, VR. When will you, this is your R and V. So remember please. So here we can, that's why here it is written for the velocity LRV, and for this your V, for width, for depth, and for width H. So now we can write where here you can very easily understand Q by M. So QM is, you need to calculate, and in the question given 25006 1 by 50 into 1 by 16 into 1 by root 1 by 16. So finally you will get 8 cubic. Qm is equal to 8 cubic, 8 meter cube per second. So option C is correct for question number 9. Question number 10, sorry. Question number 10, here the Mach number is defined as a square root of the ratio of inertia force by pressure force, inertia force by surface tension force, inertia force by elastic force, inertia force by viscous force. Your Mach number is inertia force by elastic force. Remember please. Mach for the Cauchy number is defined as the square root of the ratio of inertia force by elastic force. In the previously we have seen the Mach number, I think the compressibility force, I think here is some mistake, I think we have understand. Let me just show you. Here is Mach number is the square root of ratio of inertial force by compressibility force is not the Mach number, I think. Is Euler number. Let me just check. Let me just verify. Yeah. Let me just verify on the Google. This is the Mach number. And what about the elastic force? I think we are doing something is mistake. Let me just verify. Okay, both are the showing Mach number. Okay, that's fine. Maybe your elastic force is associated or related with the compressibility force. That is no issue. And what about the Euler number? Okay, I think we'll move on to question number 11. So question number 11 here is 1 is to 20 model of a spillway. The discharge is 8 meter cube per second. Find out the discharge in the prototype. Very easy question. Is your QM is given 8 and QP you need to calculate, and LR is 2.5. So already you know. So QP is nothing but 8 divided by 1 by 20 to the power 2.5. So finally you will get 14310 meter cube per second. So this is a very simple. Already we have already discussed a lot of time. I have already discussed. Now this is also very important. So question number 12. To apply the Buckingham's pi theorem, M is the repeating variables are selected from among us the n variable influencing the phenomena. The repeating variable are selected such that they belong to kinematic dynamic category of the variable, must always contain the dependent variable, in combination contain each of the fundamental dimension involved in the problems. None of the above. So remember please, this is very important. Option C is correct. In combination contain the m fundamental dimension involved in the problems. Remember please. So option C is correct for the question number 12. So hopefully you understand the today class, the today discussion. This is very important. So okay, bulk modulus of elasticity. Yes, it's related to the compressibility. That's fine. Okay, so thank you. So thank you for today join in the discussion. So we'll meet again on the next class. Next class may be held on. Let me just check. Hmm, yeah, it is not coming. Yes, it is on the 1st March. That's fine. So thank you. Thank you to join the session today. So thank you again.